So in this video we will see H0 H6 arithmetic instructions. So regarding arithmetic instructions, they affect or they use some of the bits or the flags register. That's the first thing that we have to remember, and mostly they affect this area known as the condition code area, right? And these are the flag bits that they will either affect or they will be using for the operation. Then apart from this area, maybe the overflow flag is also used by the arithmetic instructions. So the first instruction is add instruction, and what it does is it will add the source operand to the destination operand and will leave the result in the destination operand. Okay, so if we consider an example, this is an add instruction, and here the source is an immediate and destination is a register operand. So it will add this immediate to the value in the register operand and leave the result in the destination, that is in this AX register itself. And one of the restrictions of add instruction is both the operands can't be memory operands. Okay, so these are the allowed combinations of operands. So if we are having a register source, destination can be a register or a memory operand. If we have a memory operand, the thing is we can only have a destination as register operand. And if you have an immediate, destination can be register as well as memory. And there is another possible operand combination, that is an immediate and accumulator. So what it means is that in the instruction you will be specifying only one immediate operand, right? And implicitly accumulator or the AX register is taken as the destination. So what operand you specify as part of the instruction, it is taken as source, and AX is taken as the destination. So what does this instruction does is it will add this immediate to the value of AX and leave the result in AX. Okay, so that's the meaning of this accumulator immediate mode. Then as usual, as it is an arithmetic instruction, it will affect the condition code. So that's all about add, and these are some of the possible examples of add. Okay, then we have another variant of add known as add with carry. So what add with carry does is it will first act like add. It will add the source with the destination and leaves the resultant destination, and moreover it will check the CF, that is the carry flag. If CF is 1, right, even after this operation, if CF is 1, it will add 1 to the destination. So ultimately what you get is in the destination you will get source plus destination plus a 1 if your carry flag is 1. Okay, so let's see one example. Suppose this is your operation, that is ADC, AX comma BX. It will add the content of BX to AX, right? And if it will check the carry flag. If the carry flag is 1, the result stored in AX will be incremented by 1. Okay, so as usual, all the restrictions for add applies to add ADC, that is add with carry also. Okay, so the restriction is both the operands can't be memory operands. So these are the allowed combinations. If your source is a register, destination can be register as well as a memory, and if your source is a memory, the destination can only be a register. And if your source is immediate, destination can be register as well as memory. And moreover, like add, it supports an accumulator immediate mode, right, in which you can specify an immediate as the only operand, and the other operand, that is the destination, will be taken as the accumulator, right? So AX will be taken as the implicit operand. So and like your add, it affects the condition code. So that's about ADC or add with carry. Now we will see the subtract instruction. So subtract, what it does is it will subtract the source from the destination and leaves the resultant destination. Then all the things that applies to add and add with carry applies here also, that is the source and destination can't be both memory operands, and subtract affects condition code. So these are the allowed combinations of operands. If you are having a register source, the destination can be register as well as memory. If your source is memory, destination allowed is only register. And if you have an immediate source, destination can be register as well as memory. And as usual, if you have a single immediate source, your destination will be the implicit accumulator. So as shown here, right, these are the various possible examples of subtract. Okay, now we have a variant of subtract known as subtract with borrow, just like we have a variant for add, like add with carry. Okay, so what subtract with borrow does is it performs just like a subtract, but its final action is dependent on the CF, that is the carry flag. Okay, so what subtract with borrow does is it will subtract the source from the destination and leaves the result in destination. Then after that it will check the CF or the carry flag. If the carry flag is 1, 1 is subtracted from the destination and it is updated in the destination. Okay, so what you have to note here is in case of SBB, that is subtract with borrow, CF is known as the borrow flag, or CF indicates the borrow condition. Okay, so if CF is 1, it indicates that a borrow of 1 is pending there. Okay, then as with other arithmetic instructions we have seen, source and destination can't be both memory operands, and SBB affects condition code too. Okay, so these are the possible operand combinations. For a register source, destination can be register or memory. For a memory source, destination can be only register. For immediate source, destination can be register as well as memory, and it has a single immediate source format also, where the destination will be the implicit accumulator AX. Okay, so this shows various examples for SBB. Now the next instruction is increment. So increment, it takes only a single operand, and that single operand is a register or memory. Okay, so what it does is this operand is the destination, and to this operand 1 is added. So that's how increment acts, and the destination can't be immediate, it can be only register or memory, and it affects the condition code flags except the carry flag. So these are the various examples of increment, right? As told earlier, the destination operand, right? It can be memory or it can be register, and here one indirect addressed operand is also shown. Now we have the counterpart of increment, that is decrement. It does subtraction of the destination, where the destination can be register or memory, and destination can't be immediate, right? Just like our increment. Then, as like all arithmetic instruction, it affects the condition code except the carry flag. So these are the various examples for decrement. We have a register destination as well as here a memory destination is shown.